No, yeah.
Yeah.
All right, let's get ourselves organized. You ready?
Hey, Saturday. I'm going to the zoo. Saturday. Yeah. Yeah. Oh no,
All right. Mark received a 3.5% salary increase. The salary after the raise was this much. What was his salary before the raise? Anybody have a thought about this? Now, stop and think about what's happening. Maureen?
So, what I would do is do like 1.035x equals that new amount.
That is exactly right. That I think is the very best way of doing that. Good job. 1.035x is 36432. Because, well, what do we let X stand for? X is well, his original salary, right? So, isn't his new salary the original plus the raise? That's how she got 1.035. That's absolutely perfect. So then we'll just divide and round to the nearest cent, and that is our answer. 36432 divided by 1.035, $35,200. Perfect. Beautiful. Thank you, Ren. All right, next. Oh, a box problem. Okay, we've already done a box problem. Something a long time ago. A square side X inches is cut out right. So here's our piece of paper. Remember this box thing? So here's our piece of paper, 8 by 15. And we're going to cut out these corners and fold up the flaps to make a box, right? Write the volume of the box as a function of X. So X is the size of the corners. So we did this before. It's a box. So its volume is what? What's the formula for the volume of a box? Length times width times height. So remember, you've cut chunks out and now you're folding it. So what's the new length?
15 minus 2x.
15 minus 2x.
Times 8.
Right, because we took an X out here. All right, times, what's the new width? 8 minus 2x, and our height is?
X.
X. So there is your volume in terms of X. That's it. Don't multiply it out. Some of you did that before, and it just causes trouble. No need to. No need to multiply that. Now, when you're in calculus class and you're doing this problem without a calculator, then you need to multiply it out. But right now, there's no need to. Okay. Find the domain. Note that the model imposes restrictions on X. Well, heck yes it does. We talked about this before. If you just found this lying in the hallway, you would say, oh, that's a nice little polynomial function. His domain is all real numbers. But not in terms of this problem. Because X stands for the corners. So what are the restrictions? Smallest to biggest. What can X be? Lucy?
Has to be less than 4.
Has to be less than 4 and bigger than 0. So your domain is everything between 0 and 4. Right? Would everybody agree with that? What happens if it's bigger than 4? You can't do it. Right? Doesn't work. Graph V as a function of H, or of X, over the domain found in part B, and use the maximum on the to determine the maximum volume. Okay, And then how big should the cutout squares be to produce a box of maximum volume? So, go to your window. It says to use this domain. So x min is going to be 0 and x max is going to be 4. Now, tell me about the y's. What does the y stand for? I'm going to type this equation in.
The y.
So this
It's
is
volume.
y. So y stands for
Volume.
volume. So my minimum volume will be
15 times
0?
No.
Can volume be less than 0?
8. No.
And then my maximum is what I'm trying to find. So I'm just going to take a guess. Pick a number. 400. Perfect. Pick 400. Now let's type in our equation. And hit graph. What do you see? You should see something.
I see a
You
little
see a little hill?
hill.
Okay, now it's not perfectly symmetric, but that's okay, it doesn't matter. You see a hill, and that's all you need to see, because what is our objective? To find the maximum. So she picked 400. 400 was plenty big, right? You need to pick a number so that you can see the top of your hill. All right, let's find the maximum. Second calc max. Left. Right. And yes. I got, it looks like about 1.671 2/3 and 90.74. Is that what you got for your maximum point?
Yes.
All right, so let's read the questions again and make sure we're answering appropriately. C says, determine the maximum volume the box can hold. Is it volume Y? So 90.74 cubic inches. That's the maximum volume the box can hold. How big should the cutout squares be? .67 inches?
Yeah.
Isn't X the size of the corners? So when you find that maximum point, you got the size of the corners and the volume, so 1.67 inches. Or since that was one, if you wanted to say 1 2/3, that would be great too, because that's what it really was. Okay? Mixing solutions, oh, straight out of first year algebra. How much 10%
Yes.
and how much 45% should be mixed together to make 100 gallons of 25%? Okay? So here we go. There are lots of ways to approach a problem like this. I don't know how you did it. When you were freshmen, you may be doing stuff like this in chemistry, I have no idea. One surefire way is just to remember the little cookie cutter formula. Amount times percent plus amount times percent equals amount times percent. So again, if you have another way of doing this, because you guys truly, you did about 1 million of these in first year algebra. For some of you, that was 8th grade, a long time ago. Maybe you haven't done any since then, I don't know. This will work every time you have a mixture problem. So, what am I mixing? What do I know? I should know some of this. They have to tell me some of this information. What do I know? I know that the percents I'm mixing are 10 and 45. and the percent of the result is 25. What else do I know? I'm gonna end up with 100 gallons. Now, how am I going to describe these?
X and Y.
Well, I can call, if I call this one X, I could introduce another variable, I really would rather not, but I could, and call this one Y. You cannot call this one also X.
Oh,
Because if you call this one also X, that means these are equal amounts, and does it say that in the problem? No. So don't call it X. Marin?
you do 100 minus X.
That's what I would do. Now, if you chose to use a second variable, which is absolutely fine, you would call this Y. But don't you know that X plus Y has to be 100? So then, X or Y equals 100 minus X, so she's just kind of doing that all at once. All right, let's solve it. It's a simple little equation. We ought to be able to solve this. I got 57.14 gallons of the 10% and 42.86 gallons of the 45%. Anybody else get that? Yep. Yep. Could I have made this one X and this one 100 minus X? Yep, and the answer would have been the same. Only your X would come out to be this, and then this would be 100 minus X. Yes, 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 okay. Good deal. All right, a small satellite dish package with cardboard cylinder, parabolic dish, diameter, how tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? All right, what in the world? Can you even figure out what this picture looks like? All right, so here's my parabolic dish. Okay, now I went ahead and put it on an axis system because I know what's coming. But this is your parabolic dish. It's a piece of a parabola. Everybody okay with that? Now, it's 24 inches in diameter. So, I don't know, that's the origin. I don't know about this point, but I know X is 12 over here and negative 12 over here. Would you agree with that, the way I have it set up? And 6 inches deep. So that's 6, which means this is 12.6, and this is negative 12.6. Does that make sense to you? Now, somebody else might set it up so your parabolic dish is like this. So this would be the 0.06, and this would be the 0.246. Doesn't matter. Somehow, I'm gonna get it set up on the axis system. And you'll see why in a second. All right, the diameter of the cardboard cylinder is 12 inches. So in the middle of this, kind of like packing material, in the middle of this, we have a cylinder in there. And I know that the diameter of the cylinder is 12. So this point right here is 6,6. And this point right here is 6, something that I don't know. How tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? If, let's just suppose, I knew this right here was 1. Would I then know how tall the cylinder had to be? So what this whole problem boils down to is finding that y coordinate right there. Now, let's look at the dish. It's a parabola. The way I have set mine up, it's vertex at the origin. Parabolas, vertex at the origin, are variations of this, right? Your BFF. However, this parabola has been stretched or shrunk or something. It hasn't been moved, but it's fatter or skinnier, I don't know. So there's a number out here in front. I'll call it A. You can call it whatever you want, doesn't matter. Does that make sense to you? This parabola is opening up. It could be 3x squared, it could be 1/5 x squared, I don't know what it is, but I'm gonna figure it out. Because that point right there is on the parabola. So 6 equals something times 12 squared, right? If the point's on the parabola, it fits that equation. So what's 6 divided by 144? 24. So my parabola is 1/24 x squared. That's the equation of the parabola. Now you see where I'm going with this? What am I gonna do now? Plug in 6, and that's gonna tell me what that y coordinate is. What is that, 1.5? So now I know how tall the thing is. It goes from 1.5 up to 6. So what's the height of the cylinder? 4.5 inches. So what was the key to doing that problem? Write the equation of the parabola so that I could plug in my point and find the missing coordinate. Test?
What is the parabola under that?
I just said you can set it up in different ways.
And also, how did you get
Like 6 in for y, 12 in for x, that point right there, and solve it.
Wait, I got A.
You got what?
I got for A. I got 0.042.
Well, that might be just 1 over.
That might be 1/24.
That's 1 over 24.
Yeah.
Yeah, you don't wanna round it off, you wanna use fractions, not a decimal. It's 0.0416 something, whatever. Just make it a fraction, get math frac, and you get 1/24. All right, we gotta get moving here, guys. At a shirt sale, Jackson sees 2 shirts that he likes equally well. Which is a better bargain and why? The $33 shirt, 40% off, or the $27 shirt, 25% off? Well, you might have a gut feeling about this, but how would you do it?
33 times 0.6.
All right, so Chris says I can take the 33 times 0.4 and subtract that. what else could I do that might be one step instead of two?
1.44.
So this is what I'm not paying. So what am I paying? 60%? So it might be quicker to take 33 times 0.6, since that's what I will be paying. And then here I'll take 27 times 0.75, since that's what I'll be paying. Will Chris's way work? Absolutely. Nothing wrong with it if you like doing more math. Go for it, okay? And then you'll know which shirt is the better bargain. What'd you come up with? Which shirt should you buy? The striped one or the other one? Striped one's the best deal? Okay. Number 9. Again, back to Algebra 1. How do we find percent of increase? This question says, what was the percent increase? Anybody remember how to do that? There's kind of a little formula for that. It's real simple.
Take the
Exactly. Sydney says new minus old over old. Sometimes we think of that as original instead of old. I'm a little sensitive with that word old, but it's okay. New minus old over old, that's the way we set it up. So, for her problem, it's gonna be 82.4, that number, minus 71.065, that number, over the original, which is the 71.065 number. And that's gonna actually give us a percent. And assuming I got all my zeros typed in, I got almost 16%.
That's what I got.
Last one. On their trip, the Bruins basketball team spent 2 more hours on the interstate than they did on the local highways. So the interstate time was 2 more hours than the local highways. Okay. So maybe we'll call this T and this would be T plus 2. Does that make sense? They averaged 45 miles an hour on the local highways and 55 miles an hour on the interstate highways. So their speed here was 45, their speed here was 55. How many hours did they spend driving on local highways? I'm thinking of a framework where my journey has 2 parts to it. The distance I drive on the local highways plus the distance I drive on the interstate has to add up to 560. Would you agree with that?
Yeah.
So back to first year algebra again. How do I find distance? Not on the coordinate plane, but like distance traveling down the road. Distance equals
Over time.
rate.
Divided by time. Times.
Rate times time. Distance equals rate times time. Okay, so local highways. I know my rate was 45, and I know my time was T. And interstate highways, I know my rate was 55, and my time was T plus 2. Because I spent 2 more hours on the interstate. Does that make sense to everybody?
Yep.
Alright, let's just solve it. Easy enough. Alright, I got 4.5 hours on local and 6.5 hours on interstate. But I kinda did that in my head, so I wanna make sure, is that, anybody else did that?
I got something else. I got something else, but I'm not done.
That's what I got.
4.5.
So guys, since lunch, we've done a ton of first year algebra stuff, right? I remember all that, okay. 1.7 is due on